I am very late today to this stream, and I'm just going to do exactly 1 hour, less. So, uh, you know, I've been, I've been occupied, but um, the point is I didn't film my day 21, so I'm still here today to, solve some late code questions. And today I'm just going to go. I'll solve this palindromic substring, which is um, a similar question. I mean, it's kind of similar to whatever I've solved before. I've solved, longest palindromic substring. I've solved it's a palindrome, valid palindrome, I think. Let me just go ahead and check tag status. I, I've solved like two palindromic related questions. Um, but this time around, I'm just going to solve uh, this one here, longest palindromic sequence. This is another palindrome question, but I'm not going to solve this yet. I'll solve the palindromic substrings. Um, so this question says, given a string s, right, return. Let me just cover my stream here. So, given a string s, return the number of palindromic substring in it. A string is a palindrome when it reads the same backwards as forwards. Okay, a string is a substring is a contiguous sequence of character within a string. That is also so. Let's just go ahead and look at the example of this question. It says input s, right? S is equal to ABC. Input output is 3, right? So, um, the palindromic substring we have in this larger string here is going to be a subset of the string that is also a palindrome, right? So in this case here, we have 3 because each character in this string is a palindrome, right? So we can form a palindrome with 2 characters because A and B are not a valid palindrome, but A itself is a valid palindrome, B is a valid palindrome, and C is a valid palindrome. Now there's another example here, right? And the count for this is 3, so we have 3 and 3 palindromic substring. Um, so we have this input here is A, right? We have 3 A's. So here, the output is 6. Why is the output 6? So I'm just going to go to my board here and use this board to explain. So I'll just come here, and do this. So for now, I'm just, trying to validate the fact that, or trying to confirm the fact that, you know, a substring is indeed a valid palindrome. A substring which is, a contiguous sequence of string within a larger string. So here we have, I'll just come to take this here. Okay. So at this point, we have A, right? The first character in this string here is A. I don't know why this thing is now big. Can I reduce the stroke? It's still large. Uh, opacity. Is it opacity? It's not opacity though. Well, anyway, I think this is okay. So here we have the first character in the string. Oh no, that's not good. That's not good. So this first character here is a valid palindrome. A single character in a string is a valid palindrome because you can write A the same way you write A, normally. A reads the same way backward and forward. So you don't have, any other way to write A. So A is just A, and which makes it a valid palindrome. Um, so let me just check here. There's nobody. Okay. So the second character in this string. So we can look to the right, right? We can form another string here, A and the second A here. This is a valid palindrome, right? This is a valid palindrome, and we can confirm that we've seen so far. We've seen two palindromes, right? Two palindromes. Now, A itself at this point here is a palindrome, right? So this will make it 3. So plus 1, this will be equal to 3. This again here is a valid palindrome. That's and this A and this A2 is also a valid palindrome. So we've seen 2 more plus 2. The entire string here, right? This whole thing is also a valid palindrome. So this will be equal to 5 plus 1 again. This will be equal to 6. Oh my god, I'm just writing on that. I think I'm a bit nervous because I just started late, which is bad. But there were reasons why I didn't start early. Beyond my own control. Otherwise, I wouldn't have even streamed today. But I made sure that I showed up regardless of what happened. Okay, so let me just go over it again. Let's count the possible palindromes we have in this string, the possible substrings that are valid palindrome in the string S here. So the first one will be this character here, right? We have an A here, right? This is a valid palindrome. This A, let me just remove this again. This A and this A here is also another valid palindrome. So we've seen one and we've seen another one, that is 2. Let me just move this here. 1, 2, right? This is a valid palindrome. I will just erase this quickly. Oh, God. Okay. I'm not really good with this thing, so I just, find it hard using it. Okay, so we've seen 2 palindromes so far, right? Because we can write A the same way we'll write it forward, right? This will never change. It will still read A. Now, this character here at this point here is a valid palindrome. In fact, the best way to do this, right? The best way to do this is to count every single character in the string as a valid palindrome, right? This here is a valid palindrome. This here is a valid palindrome, and this here is a valid palindrome, which means we've seen 3 valid palindromes so far, right? We've seen 3 palindromes so far. So I'm just going to erase this. Okay, it's gone again. Let me move this up. I'll just come back here. So those 3 characters are every individual character in the string is a valid palindrome, right? Now we need to form, other palindromes as well with combinations of other characters, because we know a substring is a contiguous sequence, right? A substring is a contiguous sequence of character in a particular string, right? Or a contiguous sequence of characters as part of a larger string. So here is what we do. In this case here, right, we're at this position. We can create, another substring following this sequence here. So this first character plus this second character here, this will give us a new substring, right? So we'll have the first and the second character, A plus B, right? A plus A, right? This is not B, this is A. These are the same characters here. So this is a valid palindrome as well. A and A is a valid palindrome. So we've seen 4 palindromes so far. Now this A and this other A2 here, these 2 here are also valid palindromes, right? So we'll count them as a valid palindromes as well. This is 5, and the entire string itself, right? These three characters here are also valid palindromes, because we can still write them like this: a the same way. It reads the same way, in the normal direction, which is from left to right, and from right to left as well. So they both read the same. So here, the direction here is also the same as this direction here. So this string is also a valid palindrome, which makes it 6, right? So we have 6 characters here in this string, right? 6 substring that are valid palindromes. So yeah, that is our answer. And if you check Let's Code, this test case says it is actually 6, right? So you can see we have A. Each individual character is a valid palindrome, right? And also a combination, right? A combination of every character with the other one is also a valid palindrome. So yeah, we have this A and A, we have another A, and the whole string itself, right? Since everything is a valid palindrome, so the whole string itself is also a valid palindrome. Yeah. So now, how do we go about solving this question? Right. So to do this, I had already solved a similar question before, and I remember how I did it. So I'll just go ahead and walk you through how that question was solved. And the question was, related to finding uh, the longest palindromic substring as part of a larger string. I think, yeah, the largest sequence, right? Let me just go ahead and find longest palindromy. Let me check my profile. So here I have this. I think I solved a similar question before, and it was related to palindromes, right? Yeah, longest palindromic substring. So this uh longest palindromic substring. How do I get the question? Yeah, so this is the question here, and I'll use the same method I used here to find, you know, um, the substring, right? The palindromic substring in a larger string. So I'm just going to use that same method. And what is that method? So here's how I did it. So first of all, I try to create a palindrome or a valid palindrome from a certain point, and I call that is the center, right? So we can create a palindrome this way, right? So we can have so um this method uses 2 pointers, right? So I'm going to use 2 pointers for this question. Let me see. Um, okay, I'm going to use 2 pointers for this question, and which is what I did previously, right? So um, the 2 pointers are going to help me create a valid palindrome starting from a certain point, right? So it's going to go this way. So I have my left and right pointer here, right? And the left pointer will move towards the left, and the right pointer will move towards the right. So here's what I'll do. So in my first iteration, right, I would like to move the left pointer here and the right pointer towards this side. Now you can see if I move this left pointer towards the left, right, it means I'm going out of bound, right, which is not something we want. So we'll have to try it another way in another iteration, right? So let's say we are at this point here, right? Now, what is the possible valid palindrome we can create from this point? Yes, we can create going this way, right? We can go this way, move our left pointer towards the left, and our right pointer towards the right, right? This will help us create a valid palindromic tree. So our left pointer will start from this index here, right? And the right pointer will end up here. So we'll keep increasing as much as we can to fill up the space, right? So if there were more items towards this side, right? Let's say we had another A and another A here. We'll keep increasing, right? We'll keep moving our left pointer towards the left and our right pointer towards the right until we reach the point where the item at the left pointer is no longer equal to the item at the right pointer. So let's imagine this here was a B. So I'll just put here this was a B, right? If this was a B, then it means we no longer want to keep increasing this these pointers, and we just stop at this point here. So we'll just stop somewhere here and here, right? So this is how I was able to find, the longest palindromic substring, right? So let me just show you the solution here. So I kept increasing this. So now there are two ways to find a palindrome, right? Or there are two types of palindrome, like I explained the other time. We have palindromes that are that have an odd length, right? Let's say a value like this AAA, right? This AAA is a valid palindrome, all right. But the starting from the middle, right? We want to start creating the palindrome from the middle, which means the both pointers have to start at this point here, so that we'll be able to move them towards the right. But there are some palindromes that are not, that don't have uh, one item in the middle. Let's say, for example, we have which example should I use? We have a deed, right? Deed reads the same way forward and backwards, right? So we can start our pointers from the middle, but at two positions, right? So the left pointer has to be here, and the right pointer also has to be on the right, right? So one plus the left pointer. So which means in this case we'll continue increasing, right? We'll continue expanding the pointers until we reach the point where the conditions are no longer valid, and at each position, right? So let me call this string S. Oh, sorry, let me call this string, I'll call this Y, right? So Y, the condition will be such that Y at L, right, at the left pointer always has to be equal to Y at R, right? And in this case too, this will be L, and so if I call this X, right, X at L always has to be equal to X at R, right? So this is the condition for a valid palindrome. Every item has to be equal at both ends, whether it is at the far end compared to the beginning, right? They always have to be the same, because this means when we start reading from back to front, we'll still have the same string. So let me say did, for instance. Now if I index this with a different values, let me just put this what's the length, what's position, this 0 1 2 3. So let's say 3 2 1 and 0, right? If I wrote this the same, in from back to front, right? So D E E D, right? And I change the index, right? 3 3 2 1 0. This still reads the same as did, right? Which means the last character in the string has to, has the possibility of being the first character when the string is reversed, and will still read the same way. That is what a valid palindrome is. Now, but this question now is, wants us to, not only find out which characters in the string or the substrings that are part of the main string, right? Which of them are valid palindromes? Now we know that every character in the string is a valid palindrome, because every single character has to be a valid palindrome, right? And also combinations of characters, right? So which means we have to form that valid palindrome within the original string. So within the original string S here, right? We need to form valid palindromes, and each time we create a valid palindrome, we have to count it each time, right? So in this case, let me just erase everything. So let's say in our first iteration, right, we have here, right, we want to create a valid palindrome at this position here using this single string here. So in the first iteration, this is what we'll do, right? So we'll put our left and right pointers here. Let me just use the other color. Here I'll put left and right pointers here, right? So now when my left and right pointers are here, I'll try to create a valid palindrome using my first condition of of palindromes, right? So I have two conditions. I have a palindrome that has one letter in the middle, and a palindrome that has two letters in the middle. So the first palindrome is going to, so in the first iteration, let's say I is equal to 0, right? When I is equal to 0, we want to create a palindrome. So meaning our pointers have to start at position 0, 0, right? The left and right pointers. So we know we can't increase this to the left, nor the right pointer to the right, so we keep this at the same position. But already we know that this here is a valid palindrome because the character at s of L, right, which is the left pointer, is still the same as the character at R, right? This condition here is respected when the string is when we are at position 0, right, when I is equal to 0. So that condition was respected for a valid palindrome. Now meaning we found 1, right? So we'll count. So wow, I keep putting stuff behind me. So I'll put C equal to 1, right? So we found our first palindrome. Now when I is still equal to 0, right, we also want to find out if we can create a palindrome that has two characters in the middle that are identical. So meaning the right pointer has to be 1 plus the index here, or the counter here, the iterator here. So I plus 1, right? So I plus 1 will be equal to this place, given that I is equal to 0. Now again, we can't we can't continue increasing and decrease, or we can't continue moving the left pointer towards the left, because there will be no characters towards the left. So we have to keep this here, and because we are keeping this here, because we are not increasing this, we can also increase the right pointer towards the right, so we keep it there as well. Now this condition is also validated. We have these characters here. We will have the string A and A, which is a valid palindrome, right? So this condition here is also respected. So S at L, sorry, not I, S at L is also equal to S at R, because at this position here we can see we have A and another A here, right? A and A. So that has been respected and it is valid. So we increase our count by 1. So far in our first iteration, we've seen two palindromic substring, which were A and A and A. So in the next iteration, right? In the next iteration, our left pointer will point at I. So I will be equal to 1. Let me just write it here. I will be equal to 1, and our left pointer has to start from that position. Always, right? The left and right pointers have to start from the same position. So here, we are here. So in this case, we can move the left pointer towards the left, right? Shift it towards the side. And the right pointer will also shift it towards the side. But again, we want to validate the condition where the right and left pointers have the same character, right? So at this point, we are looking at this character here, which is A here, right? So A also respects this condition, right? So S at L, right, which is the left pointer, and S at R are also the same. So we increase our count by 1. So I'm just going to transform this. I'll do plus 1. This is equal to 3. Okay, plus 1 equal to 3, right? That's going to be equal to 3. And then what we'll do now is each time we increment, each time we try to create this bigger palindrome, we keep increasing the count. So let's move the L towards the left. So we'll move it towards this side, and we'll move this one towards the side. Now we'll compare the characters again. Now when we compare, L and R, right, this condition is still validated. So we increase our count by 1 again. So this is going to be equal to 4, right? This is going to be equal to 4. Now we'll also check for the other condition where we can, because now at this point, if you look from L to R, right, we have the string A, which is a valid palindrome, right? So we also want to do for the second condition where we can have, palindromes starting from two different positions, where the pointers are in two different positions, right? So here is my left and right pointer here. So the left pointer is at this position here. So we have another valid palindrome. This condition was validated. So we increase this by 1 again. This is equal to, okay, C plus 1 is going to be equal to 5, right? Now, in the next iteration, I will be equal to 2, right? I will be equal to 2. So we'll start the palindromes at that same position. We'll start the pointers at the same position, right? So left and right again, these two positions here. So left and right, that's where our pointers will start from. Now we know left and right. Each time we're at this point, we always need to compare, right? Left is obviously equal to right, so this is already good for us, right? So it means we can increase the count by 1, right? So we'll do plus 1. This is going to be equal to 6. Let me move this to the top. So this is going to be equal to 6. And then now the second case where we can have a valid palindrome is when the two characters are following each other, or a palindrome with the same characters in the middle, right? With two characters in the middle, which was the second condition we always check for. But in this case, we can't have that, because right can't be at this position, because there's no character at this position, there's no letter at this position, so right can't be here, right? So it means we can only check for the same position here. We can increase left towards the right, but the only condition where we can increase left, where we can push left towards the right, is when we have more characters towards the right, right? If we can push this towards the left, that means we have more characters towards the right. So, but in this case, we can't do that, so we keep this at this position, and the final value here is going to be equal to 6. So we'll return 6 as our final value, right? This seemed easy, but like, it's because I'd already solved this before, a similar question where I was looking for the longest palindromic substring, right? This is my solution here, and I'm going to use exactly the same steps I used here to solve this question, right? So I'm just going to go ahead and open my my code editor. Let me just check the stream if it is still streaming. Okay, the stream is still going on. Fine, that's okay, that's good. All right, so I'll just come here and do that. I'll just come here and so what's the name of this? Palindromic substring, right? Palindromic substring is the questions leads code 647. So I'll just come here. It's going to be part of 2 pointers, so I'm just coming here and put this here and say palindromic, right? Palindromic dash substring again, and 647, right? 647. Let me know. Let me be sure. Yes, 647. Right. So it has been created as part of the 2 pointers problem. And let me just come here and put this here. I'll copy this like that and paste it here. Okay, so let's go ahead and solve this. Okay, so the first thing to do is I'm going to keep a count, right? I want to keep a count of every every palindrome I see in the larger string, in the string S here. So I want to keep a count of each one of them, and also I want to uh check if the string is a valid palindrome. So I'll first of all create my count. I'll just call this I'll call this counter, right? Let's just put counter, sorry, counter is equal to 0. I will initiate it to 0, right? I will initialize it to 0, sorry. And I'll create a helper function that helps me check for valid palindromes, right? So the helper function is going to be called I gave it a name before. I'll just call it define valid I'll just call it valid palindrome, valid pal, or I'll just call it check palindrome, not pal. Let me make it make sense. Yeah. So now this function is supposedly the function that checks if a string is a valid palindrome. So we need to provide it a string, but I will not do that here, right? What I need to do is to just provide the indexes, right? The index at which we want to start checking for this valid palindromes. In other words, my left and right pointers, right? So these are just going to be indexes of of each character in the main string. So whatever value I pass here, I can use it to check the main string, right? So I'll just call this the left. I'll call this the left, right? Left is going to be an integer, and I'll have a right pointer also, which is also an integer. And then I want to return sorry, I think I want to return an integer as well, right? And here is what my function does. So I'll have a while loop, right? While now the condition that guarantees that we continue checking for a valid palindrome is such that the left pointer has to be superior or equal to 0, and the right pointer has to be less than the length of the string itself, and also the string at the right pointer has to be equal to the string at the left pointer, s at left pointer here. So yeah, that is all we need to do, and our while loop will keep running and helping us check for these conditions. Now the next step is to count, right? We need to count how many valid palindrome we've seen so far, given that this condition is true, right? But before we do that, we also want to move the left pointer towards the left and the right pointer towards the right. So I'll put it here like this: left minus equal 1, right? And right pointer is going to be plus equal 1. So we want to increase it by 1 and decrease the left pointer also by 1. So here, that is what we have for the left and right pointer. And yeah, so the next thing to do is to count, right? We want to count each time. So I'll put this here. I'll call this inner, or let me just say the tracker, right? This is the tracker that tracks how many valid palindrome we've seen, given the left and right indexes that were provided from the core of this function. So I'll just say this is equal to 0, and each time we want to increment this by 1. So I'll say tracker plus equal 1, right? Tracker plus equal 1, and then we return the tracker at the end of the day. So I'll just return the tracker here, right? Return tracker, right? So that's about it, and I'll now go ahead to check in my string. So I'll create a for loop for I in range of characters in S. So I'll just put length of S, right? Now what's going to happen here, first of all, we need to check if we can create a valid palindrome from any position, right? From at least with one character in the middle. So here's what we're going to do. I'll call this tracker function, right? I'll call the tracker function. I'll call the check palindrome function. So check palindrome, right? And I'll provide it the index I for the left and right pointers. So right pointer here. So I and I. So we have left and right pointers. Obviously, this is going to return the value of the tracker, right? So we'll use this to track, to increment our counter. So I'll just put counter here, counter plus equal. The function name has gone. Check palindrome. Okay, so each time we see a character, right? So let's say in the first iteration, I is going to be equal to 0. So we are providing 0, 0 here. Let me just close this. The value of I is going to be 0, 0, which means we have just one character, right? So our check palindrome is just going to go there and increment, just validate the fact that these values here are indeed a valid palindrome, and it's just going to be one character. It cannot increase, right? So meaning we've already increased this by 1. The reason being that the tracker was just increased by 1 at this point, right? The tracker was only increased by 1, and the value of the tracker will be 1 once this loop terminates, right? Because when we reduce left by 1, left is going to fall outside, right? Left is going to fall outside. Left is going to be -1, and the loop here says left has to always be equal or bigger than 0, right? And for right, right is okay, but given the fact that this is already false, the rest of the condition are also false. So we only got the chance to increment the tracker by 1, which means we've seen one character, which is also a valid palindrome in this case. So here the counter will be increased by 1. Now the second condition will be such that the two I'll say the two characters, right, following each other, is this successive characters, successive letters in the string are equal. So here's what we're going to do. I'll just say if first of all, if s at I, right, if s at I is equal to s at I plus 1. Now we need to be careful with this, because when s is already at the length of the string minus 1, we don't want to increment this, right? We don't want to do that. So we want to do, which is the same here. When you look at this solution here, right, it is almost similar, which is why it is good to have like some idea, right, or some form of memorized version of a question in your head, right? If you look at this, it's similar to whatever I'm doing right now, right? So I'm checking, right? Before I even do this, I know I need to check if I is less than the length of the string, length of the string s minus 1. Right? The reason being is that I will get to a point where I is already at this position, length of the string minus 1, and we don't want to add 1 to it anymore because it will fall out of bounds. So we just want to keep it here, right? So this and the and this, right? This and that, and yeah. So that's what we need to do, and we'll just call our valid palindrome string here again. So I will just say counter plus equal check palindrome, right? We'll pass it I and I plus 1 here, right? So this is our second condition, and all we need to do is this, and at the end of the day we just return the counter. We return the counter. So yeah, this is all the solution. This is everything, and I'll go ahead and just and test it with some test cases here, and just do this return. Sorry, I'll create a solution, right? An instance of the solution class. Solution is equal to this solution. Sorry, solution here, which is an instance of the solution class, and then I'll just go ahead and print out solution dot count substring, right? So I'll provide my own substring. I know if I had ABC, right, the value is going to be 3, right? Because each character in this string is a valid palindrome, right? ABC is a valid palindrome. But the thing is, here we can't create more than ABC. CBA is not a valid palindrome. BA is not a valid palindrome. CA is not valid. CB is not a valid palindrome. So we can't have, other combinations. We only have each individual characters that are acting as a valid palindrome, and the value we should get here is going to be 3, right? So let's run this, and you can see we have 3 in the console. If we run CCC, right, this will give us 6, right? So the answer should be 6, which is also the expected result. So let me just go ahead and run this elite code. I'll just come here, create my counter, and now this solution is not in terms of time complexity or space. Yeah, time complexity is not O of n. Is not a linear um, a linear time complexity. It's actually a quadratic time complexity, because here this loop is running, right? We are running this loop here, but then this function call is another loop, right? It's another loop that also checks for other conditions. So it will run as long as the indexes or the values we provide for the left and right pointers. So it is not the best solution. It depends on the criteria. Let's see how is all this going. S is consists of lowercase English letters, so these are the constraints here. Yeah, I'll just go ahead and run this again. Let me just run that. Now the solution has been accepted here, but let's see if it works in the submission. I expect it to work. Yeah. So wow, this is one of my best results I've gotten so far on a medium question, and this is actually, it makes me feel good. I'm happy. So I have 86.86%, in terms of runtime, and in terms of memory, it is quite the same, right? So yeah, this is good. I'll provide the link to this answer in the description. So there are more palindromic sequence questions, right? So we have another one here. What is it about? Let me see if I can attempt this. Oh, now this is this not the same longest palindromic substring? Okay, this is different from longest palindromic subsequence. Okay, let me just see. Okay, given a string S, find the longest palindromic subsequence length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no element without changing the order of the remaining elements. Longest palindromic subsequence. Huh? The longest possible palindromic subsequence is B this here. Okay. B, B, B. Okay, so a subsequence can be derived from another sequence by deleting some or no element without changing the order. Without changing. Somebody say, I'm lost. Oh my god, I didn't see this earlier. I should have checked my. Sorry, can you like can you tell me where you are lost at so I can help explain? We are all learning together, so it will be nice for me to have like this interaction with people and kind of explain my solution to them. Palindrome is equal to the same forward. Yes. A palindrome is the same backwards and forward. Yes. True. That's correct. Yep. 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 I'm still waiting for some questions. But while I wait, I will just ponder about this question here. Um. mm, 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 mm. Okay, okay, okay. All right. Um, I think somebody wants me to explain something to them, but I'm not sure exactly what part it is. So I would like to get. Should I go over this problem? Should I go over the palindromic substring question? This one that I just solved now, or should I go over the longest palindromic question? Or even there is another one, there's a third one, which was the first one I solved, right? Which is finding out if a string is a valid palindrome, right? Should I go over that too? Um, I just have like about 11 minutes left. Um, but before I continue with an explanation, um, tomorrow I think I'll start with tomorrow is a new week, and I would like to you know go over. I mean, start a new topic, right? Which is going to be backtracking. I think backtracking and two pointers are kind of related. No, not backtracking. I think um, sliding window. Yes, I'm just going to. I think I should start making posts in the community posts to kind of announce the topic for the week and post questions every day for that. Yeah, that will be much more easier. Um, you know, uh, yeah, oxygen. Zachary, my friend, is also in the chat. Yeah. Okay. So I think. Uh, uh, I'm sure. I'm sure I would need to go over this question again. So first of all, let's go back to the basics, right? What is a palindrome, right? So let me just go over to the basics and start over from scratch. All right. A palindrome is a string that is read the same way. You know, normally we read like this, right? We read from right to left, right? But a palindrome is a string that you can also read from left to right, right? An example of a palindrome is, let me use a typical example. I'll just say, um, what example should I use? We have two types, right? So I would just use dad for example, right? Dad is a valid palindrome. Now, let me just write that here. Dad. Dad is a valid palindrome because when you read dad, normally we read from right from this point to this point here. This is valid, we read that. But if you still want to read from this point to this side, you also read that, right? It still begins with a D with an A in the middle. So this is also a valid palindrome. Now, how do we check if a string is a valid palindrome programmatically? Well, one of the ways we can check this is to make sure that the character at the end, right, which is at the last index, so the length of the string minus 1, is the same as the character at the first index. So here we'll have, we start counting from 0, right? We start counting from 0. We start counting 0, 1, and 2, right? So the last character here, right, is usually the length of the string minus 1. So if we have a string that is 3, right, that is 3 characters long, which is this dot here, DAD, the length of this string is equal to 3, right? But to get this last character here, right, we need to do the length of the string minus 1. So this is going to be our position 2, which is this 2 here, right? Now, the next thing to know is that the last item in that string has to be equal to the first item, right? The last item has to be equal to the first item. And the first way, one of the ways to do this is to, without using pointers, right, is to kind of create a map, right, of each characters, a position of, a positional map. Let me just call it a positional map. So here's what I meant by that. So in DAD, right, the first character is equal to is at position 0, right? It's at position 0, and the value here is a D, right? Now the second character here is at index 1, right? That value is an A. The third character is 2, right? It's at position 2, and the value is a D, right? Now, if we start looping from the back, right? If we start iterating from the back in the original string again, let me just erase this quickly, right? If we still had DAD as our original string, right, and we start iterating from right to left, right, it means we are going to start at index 2, right? We are going to start at index 2, meaning the value at index 2 has to be the same as the position here 0, right? Which means the start, right, the first item in the map. So we need to compare the value at index 2 to the value of our map here at position 0, right? If it's the same, then we know we are on track to getting a valid palindrome. So we keep decreasing this. So this is going to be our position 1, right, index 1, and then index 0, right? What value do we compare index 1 to? Is going to obviously be index 1 here in the map, and then this last item here is going to be index 2, which is the last item in our original string, right? Now let me see, I have some chat. So for let me just move it to this screen here. For I in range of length of, if the word is, I'll come back to this again. Let me just finish explaining this. So this is what we have, right? This is what makes a valid palindrome. And to even assert this, or to even verify this, right, we can use a different example. Let's take a string that is not a valid palindrome. Let's take a bar, right, which is bar, which is an example I usually use, maybe because I've worked in a bar before. But anyway, that has nothing to do with the bar. We can use any example, right? So when we create a map from this, right, we'll have something like this. Oh, sorry. Our map will look something like this. At position 0, we have B, right? At position 1, we have A, and at position 2, we have R, right? Now, when we start looping from the back, right, from the end of the string towards the front, towards the beginning, we begin to notice a difference. Now, we always want to make sure that the value at this position here is the same as the first item in our original string, or the item that has been mapped to 0, right? But when we compare this, right, this is at 2, right? When we compare this value to the value in our map, right, the value in our map at position 0, which means the first item in the string, is B, right? This is not equal to R. Already we know this is going to be false. This is not this is not how do you say it? This is not a valid palindrome, right? We know this is not a valid palindrome, so we stop, right? There's no need to continue checking again. So this is one way of solving it, and I did that previously, right? I checked it here. Where was it? I think I solved it in, yeah, so here, this was my solution. Now this is not the most optimal solution, right? Because there are some there are some, well, I would not say it works, right? This validates a palindrome, but this is not the best way to do it, right? At least. Now, there's another way of checking if a string is a palindrome, right? Now, we know, before I even get to that, let me see. Somebody was in the chat, right? So I have, for I in range length of word divided by 2, if word at I is equal to, then continue, else return false. So I'll just I don't know if this person wants me to show the question, I mean their response, but let me just copy it and paste it so I can visualize it properly. So the person is Batman 306. Okay, so let's go ahead and check Batman's response. Batman wants me to check his response, or their response. Let me just not, I don't know who Batman is, but I'm sure. So let me just come here. So there's a fall. Oh my god, I've copied something. You know what? I'll just look at it and type it out myself. So yeah. Where is it again? Hold on. I've lost it. Okay, it's back. So they I like this interaction. So here it's a for loop. So for I in range, right? Christ. For I in range length of word. So I will have length of the word. I'll have a variable called word later on. And let me just create it at once before Python starts screaming at me. So word is going to be a string, right? I'll just put BAB, right? This is also a valid palindrome, right? Length of word divided by 2. I'm not sure why uh he's doing this, but yeah, for I in range, sorry, for I in range here, right? So if word at I is equal to, word length minus 1. Okay, word length of word minus, which is the last character in the string. Okay, length of the word minus 1, right? If this continue, right? Okay, else return what? Else what? Else return false. You have two return statements here. I don't know. Else return. Okay, I'm not sure if the what he wants me to type is complete, because he wants else return false. Else return false. Right. This is not valid syntax. So I'm just okay, maybe some other time. But there's what's a better way to check if a string is a valid palindrome, which is where I was going to write. But let me just continue with my explanation. I'll come back to this at the end. So another way to check if a string is a valid palindrome. Oh, my time is up. Christ. If a string is a valid palindrome is by checking you know the nature of the string. First of all, we have two types of palindromes, right? Now in this case I want to use a double pointer, right? I want to use a double pointer and or two pointers as it's normally called. And this the reason why I will use two pointer is because I want to create the palindrome from the center, right? So each character will appear in the center. So let's say I have this string here called dad, right? DAD, right? Now I'll have a pointer here called the left and right pointers, right? Uh, left and right. Now these two pointers will increase in different directions, right? For us to create a bigger palindrome you know as long as the string is right. So here's what I'm going to do. I'm going to come here, right? So here is my left pointer. I will increase the left pointer towards the left, or I will decrease it towards the left, or I'll push it towards the left. And the right pointer also, I'll move it towards the right. Right. This is another way of doing this. Let me just okay. I'll move the right pointer towards the right. But in this case, right, we can see that the left pointer is not pointing at anything. So this in this case here, right, this is outside of the string. So we don't have this is not going to increase. But what this says is that what this condition is looking for is that the first character here, right, is oh my god, why is this thing not working? Every time I write an R, right, I'll just write it again. This condition is checking, at any given point where the left and right pointers appear, right, there has to be a valid palindrome, right? So the character at the left pointer has to be the same as the character at the right pointer, right? And that makes that character a valid palindrome. Now we need to continue increasing, right? So we move in the next iteration, we could have the left pointer at this position and the right pointer here. Now you will see why we need to increase it as much as we can. So in this place, we want to check again, right? We move the left pointer towards the left and the right pointer towards the right, right? Now, when you look at this position, you can see that we will be able to form a string, right? Because at each point, we always need to validate that. So when L is here and R is here, the characters have to be the same. Let me just call this string. Let me call this string a Y, right? Y at sorry, Y at R has to be the same as Y at L, right? These two strings always have to respect that condition. So what do we do now? We move the left and right pointers, right? We move the left pointer towards the left and the right pointer towards the right. And this still respects that condition, right? This still respects the fact that the character at R, right, in this Y string here is the same as the character at L, right? The left and right pointers are pointing at letters in the main strings that are always going to be equal, right? So far we'll have, in our first iteration, we'll have a palindrome which is D, right? We had D at first, and then when we started from here, right, D, and then we increased the sorry in the second iteration we started from A, which is also a valid palindrome, but then when we move the left pointer towards the left and the right pointer towards the right, we begin to create a bigger string, right? We have D, A, D, which is also a valid palindrome, right? This condition will always help us validate if a string is a valid palindrome or not. Now this is the condition, the case where we have what is the time now? Oh my god, I'm running late. So this is the condition where we have a single character in the middle, right? This A here, right? This is going to be a value. But in the case where we have something like this, let me just erase this quickly. I'll remove everything. Our string is now like this. Let's say I'll call this X this time around. S is equal to D, right? DED, right? Now we have two items in the middle, right? This is great. So meaning our left and right pointers have to start in different positions, right? So left and right pointer will always have the same value. So we'll have our left pointer here and our right pointer here, right? So meaning at this point these two values are equal, which is also a valid palindrome. E and E are valid palindromes, right? E and E are valid palindromes. We are okay with that. So we need to create a bigger palindrome from the center, right? I don't know what to call this, but like it is creating a palindrome from the center of the string. So and how do we know we are even in this at the center of the string? We always need to start from the first part here. We always need to start from the beginning, and check for possible case where we can have two characters that are following each other, or two successive characters that are valid palindromes. But in the first iteration where I is equal to 0, we will not find that. But when I is equal to 1, right, when we have the left pointer at this point here, we can have the right pointer here too, right? The right pointer can be here, and then we'll begin to expand them, right? We'll begin to expand them again. I'll just remove this too. So we'll begin to expand them like this. We'll begin moving this to the left, and then this also to the right, like this. So we'll move this to the right, and you can see when we look within this range, right, from this point to this point here, from this point to all the way to this point here, we have a bigger string called did, right? This will create did for us. And that is another way we can check if a string is a valid palindrome or not. If we had another character, let's say A here, right, this is no longer a valid palindrome, right? This is not going to be a valid palindrome because R here is not going to be equal to L here, right? So but this question is quite different, right? The question wants us to find how many palindromes do we have that is part of a bigger string, right? Each character, we know each character at any given point in a string is a valid palindrome. Now we need to create combinations of characters subsequent characters to be able to get a bigger string, right? Or at least a substring that is part of a bigger string that is also a valid palindrome. My time here has elapsed, but let me just check here. Did you go over linked lists, stacks, or queues? I've done stacks. I've done just stacks, arrays, and strings. This week I was, doing only two pointers, so I've not done linked lists. So I'll be starting those in the future. But next week I'm sure I'll be doing, um, you know, next week I'll be what did I say I was going to do? A sliding window, right? And so on. So I will take oh my god. I hope this stream doesn't end. Okay, the stream did not end. My network is quite bad. But um so I want to see this person's solution, but unfortunately I'm running out of time. It's already 11:25. I need to prepare for work tomorrow. I need to prepare for other things tomorrow. um I hope I'll see you in the stream tomorrow again, and maybe you can, you know let me just push this quickly to yeah. I've not gone through binary trees yet. You can see a progression of everything I've been doing so far. So this is day 21, right? Day 21 over 100, right? So everything I've been doing, right, is in the title. So 100 days of data structures and algorithm. Then the topic I'm doing for that particular day is, you know, you know, in the title as well. So, did you go over binary trees? I've not gone over binary trees yet, but I will do binary trees later on. So I'll do git add, um, git commit dash m. What's the palindromic substring? So I'll call this palindromic substring, right? Which is lead code 6647, right? So you can clone uh, my repository. I've left a link in the description. You can go there and, download all the questions I've solved so far. Uh, yeah, git push origin main. Yeah, so you can get every questions there. It's a so I work as a web developer, mostly on the back end. Um, yeah, so I am in Nigeria, and yeah, that's it. The best way to even do this is to always follow up with the way I study, right? With every topic each day, solve questions, try and memorize. Sometimes you need to memorize something so that you are able to recognize those patterns, like I did today with this palindromic substring, which really excited me because I would have struggled with this question. But because I solved a similar question previously, I was able to remember how I did it, and then it just took me less than 15 minutes to figure this out. All right. I'll see you guys tomorrow with a new topic, and I think I'll begin to share my the questions I've solved, and everything in the description or in a community post. You can also join me on LinkedIn. I have my link to LinkedIn in the description, and I come live every day to solve at least one lead code question. And the goal is to become good at data structures and algorithm. I'm learning live. I'm also, trying to show how this goes. And yeah, so just keeping up the good work, right? Okay, it was nice. Today's session was good, and I will see you guys tomorrow. Okay, do I have a Discord? No. Okay, I think I should create a Discord channel, right? Um Maybe I should also do a Q&A session some other time. Uh all right. I'll stop by tomorrow. I'll see you tomorrow again. Good night. Okay.